Hi class, it's Mrs. Gooch again. So here we are talking about compound events. So I can find the sample space of a compound event, and I can find the probability of a compound event. So when we're talking about compound events, as our topic is, what we're really looking at is another way of using tree diagrams. So let's look at this example. So we're going to find the tree diagram for this sample space. When we go to the store, we could either buy a pizza with thin crust or stuffed crust. Then we could choose a Hawaiian pizza, the Mexican pizza, the pepperoni pizza, or the veggie pizza for each of the types of crusts. So you can see that my sample space is I have 8 possible outcomes now. I could have a thin crust Hawaiian, a thin crust Mexican, a thin crust pepperoni, a thin crust veggie, a stuffed crust Hawaiian, a stuffed crust Mexican, a stuffed crust pepperoni, and a stuffed crust veggie. So you can see I have 8 possible outcomes, and it's really easy to see that with the tree diagram. However, we figured out that we have 8 possible outcomes. But can you find out that without drawing a tree diagram? And the answer is yes. There's a very simple way of doing it. So that brings us to the big topic of today. It's called the fundamental counting principle. It means that you multiply the number of possible outcomes for each event. So if we have 3 events happening, we would have 3 numbers being multiplied. In our last situation, we had 2 events, so we had 2 groups of numbers. So let's look at this again. So here, we have 2 types of crust. So we have 2 types of crust. And here, we have 4 types of pizza. So 2 times 4 gives us 8 possible outcomes. And really, that's all the fundamental counting principle does for us. So let's look at another example. We need to find the total number of possible outcomes of rolling a number cube and flipping a coin. Well, I have to think about a number cube. A number cube has 6 possible outcomes, and flipping a coin has only 2 possible outcomes. So now I go 2 times 6, that equals 12. There are 12 outcomes possible. All right, let's try a harder one. All right, here we have different outfits that you can make. 7 t-shirts, 4 pairs of jeans, and 3 pairs of shoes. So let's break this down a little bit more. I struggle to read things like this, so I need to break them down more for myself. So I have t-shirts. And those t-shirts, I've got 7 of them. So now I have jeans. And I've got 4 pairs of jeans. Then I have shoes, and I've got 3 pairs of those. So now I take and I go 7 times 4 times 3. So if we times 7 times 4 times 3, what we get is there are 84 possible outcomes for outfits out of just that little bit of clothing. Now, would you really want to make a tree diagram for this is the next question. So I'm going to start a tree diagram and just let you see how it kind of goes out. So I'm just going to number my t-shirts 1 through 7. So 1, 2, 3, 4, 5, 6, and 7. And then I'm going to number my jeans. So 1, 2, 3, 4. 1, 2, 3. You see how it gets really cramped really fast? Well, by the time we get done, we end up with 84 possible outcomes. So I wouldn't want to write out 84 possible outcomes, would you? That's why the fundamental counting principle is so important to us in math, because we makes it so much easier. Okay? But remember, when we're doing it like this, these are all independent events. Let's try another one. Here is a spinner. Okay? So it says, find the total possible outcomes of spinning the spinner and choosing a number from 1 to 5. So I'm reading this very carefully, and I see that my first thing is I'm spinning a spinner. And the second thing I'm doing is choosing a number. All right, so my spinner. So I'm looking over here at the spinner, and I see that the spinner has 4 sides. So my first outcome number would then be 4. Okay? Now, it says I'm choosing a number between 1 and 5. All right, so now I'm looking at my second possible event, and I see that I have the numbers 1 to 5. So if I count that, 1, 2, 3, 4, 5, I have 5 possible outcomes. So 4 times 5 equals 20. There are 20 total possible outcomes from combining these 2 events. Let's try another one. I think we've already done that one. All right, let's look at this one. How many 4-digit passwords can be made with the digits only? Okay. Now, this is actually a really interesting question. So we have 4 digits. So let's talk about this for a second. We've got 4 digits. 1, 2, 3, 4. And then if we think about the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we have 9 possible, wait a second, let's try that again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 possible outcomes. So here, I could choose 10. Here, I could choose 10. Or here, or here. So now, I times 10, times 10, times 10, times 10. And that gives me, there are 10,000 possible outcomes. Do you want to write out by a graph or a tree diagram 10,000 possible outcomes? No. Let's look at one more. Let's see. All right, so that's what we covered today in class. Have a great day. Bye.